Hello everyone, this is the video for CHEMBLAST, Chapter 1, Question 1. We have 3 questions for Question 1A. Let's look for the first one. You have to write the notations for all isotopes of iridium. The mass spectrum is given for this question. You can see from the x-axis, we have 2 spectrum for 2 isotopes of iridium. So I'm going to write it down as the first isotope is iridium 191. Or you can also write it down in a form of isotope notations. And 77 is the proton number that you can refer to the table of relative atomic masses. And another isotope is iridium 193. So 2 marks for each isotope. Next, we have to calculate the percentage abundance of each isotope. The spectrum is given in terms of relative abundance for y-axis. So you have to calculate the percentage abundance for each isotopes by comparing to their relative abundance. So we have the first isotope, which is iridium 191. So we have 5.0 is the relative abundance for these isotopes. You times with 100%. So you have 38% for percentage abundance of iridium 191. And the same method for iridium 193, just change the relative abundance value here. You will have 62% for iridium 193. And you can see the spectrum for iridium 191 is a bit shorter compared to iridium 193 based on these values. Next question, we have to calculate the relative atomic mass of iridium. So there are 2 steps that you are going to use. The first one, try to calculate the average atomic mass using this formula, summation Kimi, summation Ki, Kimi Ki. So just put all those values that you have from the mass spectrum, you will have 192.2 AMU. This is average atomic mass for the first step. I'm going to use the same value for the second step to determine the relative atomic mass, which is the symbol is AR. So you have this value by comparing to the mass of 1/12 of carbon-12 here. You can see this one. So we have the same value but with no units anymore. Next, for the question 1B, what you have is copper consists of 2 naturally occurring isotopes, namely copper 63 and copper 65. What you have here is the average atomic mass for the copper. Here is the value. And you have the atomic masses for each isotopes. You have to calculate the relative abundance of each isotopes for the copper. For this question, we have tips to solve this problem. You have to understand the total relative abundance for all isotopes is either 1 or 100%. So we have to assume, let's say, you assume that abundance for copper 63 is X. So the abundance for copper 65 is 1 minus X. X is the value that we need to find out. So take out the formula of Kimiki. The subject is average atomic mass of copper. You have the value here, which is this one, 63.546 AMU. And then you put all those assumptions that you have here into the formula. Rearrange to find out the value of X. After that, we are going to do the conclusion. And then, continuing from this value of X, I'm going to put this final statement as my conclusion. So the abundance of copper 63 is the value of X itself. You can also convert to percent. And the abundance for copper 65 is 1 minus the value of X. So you have the final answer. That's all. Thank you for watching and all the best with the next questions.